This video provides a virtual walkthrough of the MEG Lab. When you enter the space where the MEG Lab is located, note that you are entering restricted areas governed by MRI zoning policies. Check with your supervisor and those in charge of the MEG operations to confirm that you have been given the necessary orientation to enter this area. You will go through the two sets of double doors to enter the hallway where the MEG is located. As you walk towards the MEG, you will pass two MRI suites. You should not enter these areas without additional orientation and permissions. Stay in the hallway. The MEG suite is located on the right-hand side down this hallway, around a corner from the MRI suites. Walking down the hallway, you may encounter large dewars. These dewars contain liquid helium and are used to keep the MEG operational. Do not move or handle any of the valves on the MEG helium dewars. Before entering the MEG suite, let's walk past it slightly and note the location of the left-hand wall. Note that this wall is adjacent to the MSR in the MEG and should be considered part of the no rare earth magnet zone for the MSR. The MEG suite is locked. You will either need to enter a code to unlock the suite or someone will let you in. Do not leave the MEG lab unattended. Lock the door behind you if you need to leave for any reason. Let's enter through the double doors. You will be greeted into a space which contains several operational areas. The MSR, where the MEG doer, gantry, and patient support is contained. Patient monitoring and stimulus patient interface equipment are also found in the MSR. The console area, where the acquisition computer, stimulus computer, and stimulus controlling hardware are found. The electronics area, which is tucked around the corner from the MSR. This is where the MEG electronics is situated and the helium refill equipment is located, including bottles of gaseous helium. This area should be considered off-limits unless you have been given explicit instructions to enter. In the case of a problem with electronics hardware, please contact a designated MEG operator for assistance to reset them. Let's walk through each area in detail. The MSR is like a big vault. The walls are made with layers of aluminum and mu metal, which is a copper-nickel alloy. The layers are fused together with rivets to create barriers from external magnetic fields. The effectiveness of the barrier is frequency dependent. The walls, including the ceiling and floor, should not come into contact with any large magnetic fields, as this can cause the shield to be permanently magnetized, thus degrading the shielding's effectiveness. The general rule is to avoid bringing anything above the size of the Earth's field within 3 meters of these walls. Note the walls are bounded by the outside wall in the hallway, the wall that opens into the console area, the wall next to the electronics alcove, and the wall adjacent to the office beyond the MEG lab. There is a false floor, and below that is the parking garage, and there is a gap in the ceiling area above the MSR and the floor above. There is an intake and outtake vent inside the MSR, which you can find by looking up to the ceiling. The MSR has two types of lights, regular white lights and IR lights. Follow the video on light operation to learn how to turn these on and off. Please take care to operate the MSR door carefully, as there is a risk to your fingers being crushed if operated improperly. Please follow the MSR door opening and closing video for details on safe operations. Finally, note there are various mechanisms in place to open the door should the door not open using the normal open procedures. Note that there should be 2 Allen keys, one on the inside and one on the outside of the MSR. Do not switch these keys and never close the MSR unless these keys are in place. The MSR contains a few special openings called waveguides. One such waveguide can be found on the front wall on the lower right-hand corner. The holes are used to pass cables through the inside of the MSR. Never disturb any of the cables that are already passing through. Note that some of them have a special wrapping called zipper tubing. Sometimes this tubing is grounded by the MSR by connecting the inside shiny bit with the MSR metal. Moving these bundles, therefore, might disturb the special grounding, which might add noise to the data. Let's look inside the MSR. Inside the MSR, you will find the MEG doer, which is supported in its upright and horizontal positions by a gantry. A patient support permanently set up as a bed for this MEG scanner is in front of the doer and gantry. On the back right corner are the Guillemot flow meters and the wire and box to connect the level meter to read the volume of the liquid helium inside the MEG doer. Along the right-hand wall are various hooks that hold cables such as the head coils and EEG electrodes. As well, on this wall, there is a table where you will find the EEG box, which includes the head localization connectors and EEG testing equipment, such as a current generator. The VPIX boxes are on one of these shelves as well. Please note that the EEG box creates noise that can be seen by the MEG. Thus, please keep the table and the EEG box as far away from the MEG doer as possible. Let's now look at the tall cupboard at the front right corner. The top holds the intercom speaker and the monitor for GA patients. The phantoms are also kept on this shelf, as well as miscellaneous supplies. Inside the cupboard, you will find stimulus equipment such as the audio speakers, the photodiode, and SEF connectors. On the ceiling, you will find a slidable mirror, which is part of the projector system. The screen is attached to the doer and can be angled and extended as needed. There is Velcro around the screen for you to attach the photodiode. The rest of the mirror system is along the inside front wall where you will find the opening of the projector. Along this wall, the patient monitoring cameras and microphone is attached. There is a wooden chair on the back left corner. This chair is deemed magnetically compatible and can be used inside the MSR. Next, let's have a look at the console area. This area contains a long table with computers, MEG, and stimulus hardware interfaces. Additional stimulus hardware, switches for lights, and helium level monitoring can be found on shelves in front of the MSR. As well, GA equipment used for patients is found on a cart near the MSR. The acquisition computer and stimulus computer can be found on the floor below the table. The acquisition computer monitors are the two large monitors on the console table. The two monitors are separated by a smaller monitor. This is the patient monitor. When you turn this monitor on, you will see the inside of the MSR. Always have the patient monitor on when someone is inside the MSR. The stimulus monitor sits on top of the CTF ECC hardware. The ECC hardware interfaces external inputs to the CTF MEG. Several easy-to-access BNC connectors can be found on the front panel, along with indicator lights that show the status of various auxiliary channels and power status. There are also connectors on the back that can be accessed. The BNC connectors enable signals generated by the CTF electronics to be connected to devices, as well as enable signals generated by external devices to be read simultaneously into the CTF electronics during acquisition and acquired as auxiliary channels. On this console table, you will also find the patient intercom, the audio hardware, and the VPIX button box hardware. The SEF stimulus equipment is located on top of the shelf next to the MSR, and cables from it are fed through a waveguide opening on the MSR wall near the shelf. The equipment to monitor the helium level is found on the middle shelf. The equipment to turn on the IR and regular lights are found on the bottom shelf. Above this shelf is the O2 monitor, and the projector is suspended from the ceiling. The electronics area consists of the CTF electronics, including the rack, the EEG power, and the fan power. Beyond this, you will find the equipment for helium fills. Note the location of the gaseous helium cylinders. These are stored in cylinders which should either be securely strapped to a wall or secured on a cart designed to hold the cylinder. When moving the cylinders, the canister's top should be securely in place. Let's have a look at some safety considerations in this lab. The first thing to note is the O2 monitor. The MEG Doer contains up to 90 liters of liquid helium. 1 liter of liquid helium expands to over 757 liters of gaseous helium at normal atmospheric pressure. This means that in the event that helium leaks from the Doer, it could displace the oxygen in the air. Although quite rare, sometimes a spontaneous warm-up will occur unexpectedly, and you should be prepared to react. One of the systems in place to monitor such events is the O2 monitor. There are 2 parts to the O2 monitor. The first part is located on the top right-hand side at the front of the MSR wall and includes sirens, a strobe light, and a reading of the percentage of O2 in the MSR. The second part is located inside the MSR on the right-hand side next to the door opening. This is where the O2 sensor is positioned, and this is where the percentage of O2 is being monitored. When the O2 level drops below 19%, a high-pitched sound will be heard. If the O2 level drop is sustained, a louder klaxon sound will be heard, and the red bulb will start flashing. Unless you are doing a fill, if the O2 alarm sounds, you must suspend any data collections and remove the participant from the MSR. Anyone in the MEG console area should evacuate. Follow the directions in your emergency procedures manual. Re-enter only after you are cleared to re-enter. It is important to follow these procedures even if you think it is a malfunction of the device. Never use the MEG if the O2 monitor is not functioning. Note that it is routine during a fill to unplug the O2 monitor. Make sure the O2 monitor is plugged back in before you proceed with any experiments. Another system that you should use to monitor for a spontaneous warm-up is a camera used for patient monitoring. Always have both the camera and microphone on and keep a close eye and ear on the activities inside the MSR. A sign the oxygen is being displaced would be seeing white smoke or hearing a hissing sound coming from the MEG Doer. Even if the oxygen monitor does not sound, remove participants from the MSR and follow your emergency procedures. Because helium rises, you should drop to the floor to maximize oxygen levels as you exit the MSR. The next safety consideration we will review is the MSR door. The door can be a hazard when closing it. Please review the video that outlines the door operating procedures. Always leave the MSR door wide open when not in use. This is to avoid any accidental pressing of the open and close buttons that will cause the door in the closed position to seal and unseal. This process poses a potential harm to anyone unfamiliar with the door operations. Placing fingers near the edge of the door will crush the fingers. The MSR door is also very heavy, and there is a small risk that the normal locking opening mechanism might fail. This is very rare, but there are safety features built into the design should such a thing occur. The procedures that follow outline the procedures available to you. There are additional procedures that can be followed that will not be described here. If the procedures described below fail, follow your emergency procedures manual or call CTF for immediate assistance. The contact details for CTF are found in your emergency procedures manual. If the black open button fails, there is also an open button on the inside of the MSR. If possible, ask the person inside the MSR to push the black button. If both fail, push the red button to release the air pressure. There is the same red button on the inside of the MSR. Ask the person inside, if able, to push the red button. Finally, there is an Allen key located on the inside and outside of the MSR. Use your Allen key and place it in the hole in the middle of the door and turn the key in the direction of the arrow. You will need to give this a good turn. This will disengage the locking mechanism. Similarly, the Allen key and hole on the inside door does the same thing. It is at your discretion whether your participant inside the MSR should take part in these procedures. If these fail, follow your emergency manual procedures or call CTF for additional instructions. The final safety consideration we will discuss relates to the MSR walls. As indicated previously, you should avoid magnetizing them. Keep strong magnets 3 meters away from the walls. A strong magnet would require some force for you to pry from a piece of ferrous metal. As well, it's important not to do any renovations around the MSR walls that might perforate the walls. Perforating the walls will greatly reduce the magnetic shielding effects. Always check with CTF before performing renovations near the MSR walls. This concludes the walkthrough of the MEG lab. Remember that you are sharing the lab with the clinical team. Be aware that the MEG equipment has been configured optimally for the clinical scans. Remember to return the MEG to idle configuration before leaving.